So today's topic will be audits, quality, and historical data analysis in the context of quality and audit data. So yeah, that will be more interesting than the last time where we just tackled some basic stuff. This will be really helpful for you in your operations. So housekeeping, as always, you are all muted. You can just listen to us. If you have any questions, please use the icons in the Zoom tool and yeah, state your questions, and we do our best to answer these questions at the very end of the session. If we don't find time to answer all the questions, which might happen, we will come back to it maybe via email,
or
something. Yeah, or maybe in the next session. Really depends on what you're asking. Okay, really good. So next thing, let's introduce ourselves briefly. So we have Frank here. Maybe you take over.
Okay, I have to read what's written now. Okay, so if you don't know or whatever, hello to everyone who knows me. My name is Frank Pietracupa. I'm from Nitrix Metal here in Montreal, Canada. Been with Nitrix forever, and really glad being here. And I'm glad being on this this QMULUS team because it brings my knowledge of furnaces and the experience of using a furnace. Okay, so it's one thing where you just design and ship, but it's another thing when you design, ship, and then install, and then you crack your head because how do you use this? And if we change this, it would help the life of the person, or of course also software, right? How you load something, how you do something. So I'm glad being in this team.
Yeah, thanks, Frank. Also, I'm really, let's say, thankful that we have you in this team, especially regarding quality and audit. Yeah, since you have a lot of experience in this topic and you work closely with the development team to design the applications as they are today. So
yeah, that's the thing, because it's not just a software that is it's to be used in a easy way, intuitive way, but it has to give you your results and has to save time. So it's good having that hands-on, where a developer, I mean, you obviously you know your world, but you can't know everything, right? So yeah, it's a good team.
okay, yeah, next one myself. I joined Nitrix 4 years or 5 years already, I'm not sure ago, and in the lead for software and digitalization. And yeah, my main, let's say, challenge currently is QMULUS. It's a really great project as well, and we are evolving every day, every week with the project and the product. And yeah, we're doing our best to meet the customer's expectation and needs. So that's really good. Don't have today with us Kurt Willems, but I want to show you, and we will always show you in every webinar. So this is the responsible salesperson in North America for QMULUS. If you have any questions, reach out to him, and he will make live presentations for you happen, whatever you need.
Yeah, I think
we have
he's. Oh, sorry.
No,
I was just gonna say that
yeah.
he can't join us because he's way out east right now.
Okay.
Sorry, west.
Okay, his counterpart in Europe is Daniel Goncharek. So yeah, joined Nitrix a year ago, I think, and his main sales task is QMULUS. So he knows everything about it. He can also consult you with special, if you have special questions and so on. Yeah, feel free to reach out and state your questions, ask for a presentation, whatever. Okay, so as already mentioned, we are in the 5-part series. Today is the second appointment, the second session. We are talking audit, quality, historical data analysis. There will be more sessions, 3 more. After that, one in December about data analysis and insights, January about asset and process management, and the last session in February about advanced tech. So this is really about how we can use AI, machine learning to automate stuff, to facilitate our daily work. Okay, so let's directly jump into it. So what are is the agenda of today? The whole session will roughly take 45 minutes. First topic is a case study about audits. Second will be a case study about quality assessment. Second, the third one will be a live presentation, how we are solving things in QMULUS, so apps and Spotlight. The fourth one will be electronic audits. Are they allowed? So this is, I think, a general question, and it's of general interest to answer this question. And last of us, it's about your questions. So feel free to state as many questions as you like, and we will go for it. So let's dive into it. First thing, yeah, okay, a note as always, everything what you're going to see later on is artificial data. We are talking about the development environment. We are showing the development environment. Data might not behave as usual. Processes are faked sometimes. Numbers are faked, and yeah, so that's just for your for you to know. So don't wonder if something looks weird. Okay, case study audit trail. So I think this is a good good point in time to hand over to Frank. I think you have some good stories about that. So yeah, here we go.
All right, so I'm going to start from way in the past, where an audit, a temperature audit at this point, we had paper charts on the control panels. Every furnace, every asset had some sort of a temperature recorder. An operator would load the parts and start some sort of a temperature, right? A cycle, a Honeywell set point or something, or the furnace is already at temperature. You put the parts in. Now, the parts go in cold, the parts are going to heat up, and an operator would write a work order number, either on the paper itself or on your work order. Parts were entered at this time. Then half an hour later, I walk back, I look and I take a look at the chart and I see, okay, they reached soak temperature exactly 6 minutes ago. So that was, I don't know, 12:02. 12:02 plus 2 hours. 2:02, I need to come back here at 2:02, set a little timer. It's going to ring a bell at 12 o'clock, knowing that I have 2 minutes to get back here, so I have to take the parts out. I write all my notes. I write all my little samples that I may have put in. I write all my comments on the actual paper, and the bell rings. I run over. I take the parts out. Obviously, temperature drops. Obviously, the door opens. Obviously, that type of thing, and I continue with my day. At the end of the day, all these papers around the shop are, as Michael Winter would say, in Adidas network, i.e. running shoes, going around taking all these papers and bringing them to the front desk. And then someone the next day is going to pull out the papers, audit the papers. So did this part go in this furnace and soak at that temperature for that amount of time? So all of this is very, very, very manual, right? And of course it's good, stamp, I sign, and these parts are released to the next step. So that was before. Moving on to today. Okay, so now we have our Honeywell, our Nanodax, our controllers have, yeah, next slide. Our today's world, I have some sort of electronic information. So I have time, temperature, like constant. I know every temperature, every moment, all the time. So again, kind of the same idea. I take my parts, I put them in a furnace, and I say start. Either run a recipe number 16, or again, this thing is soaking at 500 degrees C. I put my parts in, and 4 hours later, I need to pull them out. But now I have temperature in an electronic format. I go again with my USB stick, or there's already a network. So from my laptop, I go to Furnace 4, download CSV, and now I have Excel. Excel gives me tons and tons and tons of data. So now I basically say, okay, this was the job, this was the furnace, this was the temperature, the time it came, or the date it was pulled in. I look at this, the data from more or less that time, right? So I make this huge, long Excel sheet. I take this opportunity to make my life easier, highlight a couple of colors because, well, this was my temperature set point. This is tolerance minus, tolerance plus. Just to make my life easier, I put them here, those last 3 columns on the right. And I scroll down temperature and I look at, main TC, TC1, TC2, whatever temperatures may have, whatever thermocouples may have been connected or required to be connected. I scroll down, page down, page down, page down, see the temperature rise 100, 200, 300, and then, 390.1. And my minimum was 390. Great. So I highlight, like if this were paper, I would have highlighted with a highlighter. So thermocouple came in at this time. And of course, I should not exceed 410, right? So I look at my 4 columns. In this case, I have 4 thermocouples. They came in at this time, and then I page down. So I go down, and I'm looking that none of these thermocouples went below 390. None of them went above 410. Page down, page down, page down, page down. So I had determined when it entered, and now I look when it leaves the zone in question. So I see now that the temperature is 390, 400 degrees, and finally it's going down 397, 395, 392, 390, 389.6 in this case, first one. And that's the first time that it exited the zone in question, right? So now I know when it came in, at the time it came in, I know the time it came out. I know that I didn't exceed, I didn't go below 390 or above 410. So I now go to my, I do my math, T out minus T in is my soak time, right? So I clean up my Excel. Of course, I can't show you the whole time because it's hours long. So determine my time of entry. I scroll through my data, confirming that no actual value exceeded my tolerance band. I determine the time of exit. T out minus T in is my soak time. So I determine what my original requirements was. I needed to soak for 3 hours, whatever, minus 5 plus 30 or something like that. I determined that, yes, I soaked for 3 hours plus 6. So I'm good. I comply. I sign off. So it's a different method currently used extensively. And it is labor intensive to some degree. Well, it's labor intensive, that's for sure. It's very accurate because when I had paper, there's a fraction of an inch or a couple of millimeters difference between 390 and 410. So I really have to look with my magnifying glass to see, yes, is it above 410 or below 410? Like, did I touch it? Did I exceed it? It's hard to see. And it's a little bit subjective. Here, it's a lot less subjective. So
yeah, but Frank, it gets really complicated if you get even more sensors, right? So this is an easy example. So if you just imagine having multiple of these, for example, I heard of a vacuum furnace we installed lately with 9 thermocouples.
This brings up now the skill of the person, right? So when you have paper, a person that has been doing this forever, a quality assurance, quality manager, quality person that has been doing this for years, has the eye for it, knows what to see. I would bet that a young hiree would not see the same thing as someone with experience. So now the quality of your employees, the experience of your employees is crucial. With Excel, it's a lot less. I can technically do condition formatting and my cells and just, if it's below 390, turn it red. If it's above 410, turn it red. So I could visually see any anomalies. It's easier to see. But we have something better now. All right. So the data is coming in. Your computer knows all of this. And QMULUS knows all of this. Well, now, if I tell QMULUS, well, if I'm above 410, if I'm below 390, give me a visual indicator, right? Start at when TC1 entered set point -3, or when when the TC1 entered the zone, whatever. I define that start point. I have an endpoint plus or minus tolerance. Now, what I defined physically is I defined this rectangle, which in this PowerPoint is shown in green. So that rectangle was defined by someone with knowledge and someone with experience and someone that knows the spec. This is the thermocouple needed. It does not need be furnace thermocouple, low thermocouple, coldest thermocouple, hottest thermocouple, whatever. Pick this thermocouple. When it reaches this point, you start the time. And furnace thermocouple should not exceed plus or minus this. And your duration is that. And that envelope, we'll use the word envelope later. That envelope is defined and will be copy pasted to all the recipes. And in this case, I could even say this is the envelope for recipe number 4. And now every time I run recipe 4, I load that specification. And you can see that green button, load specification set. So recipe for, or parts Boeing or parts Tesla. I'll show you Tesla parts later, which is no relation to real Tesla. So basically the operator has less knowledge. I just pick my specification set, done. And what's stopping us from making this automatic as it's running?
Yeah, perfect. So let's dive deeper into it later on. So let's briefly talk about quality assessment, which goes in the same direction somehow, but with some other benefits we would like to point on. So be excited about the live presentation Frank is doing later on about audits and quality, and we will see that how in detail these specifications can be built within a couple of minutes. So nothing to be worried about and really easy. So let's talk about how quality assessment goes on currently in the, let's say, in the heat treatment industry. So you have a process which is producing certain kind of products, and all these products are, let's say, analyzed by internal, external laboratories. The results will come together to a, what is it called? A quality manager, and the quality manager then decides, okay, this part is produced in the correct manner. It's good, we can ship it, or it's not good, we cannot ship it. And here it stops usually. Yeah. So the part can be scrapped and it's thrown away. Lessons learned in question. But we should ask ourselves, why was the outcome bad? Why is the product in a bad state and not what we expected? Was it a process? Is it maybe the preconditions of the part? I don't know. Yeah. But with QMULUS having all the things in hand, it should be our goal to improve the processes and also the preconditions of the parts, maybe if possible, to optimize our overall processes and the overall quality we are delivering, so that these, let's say, not that likely outliers, scrap products, really, how to say that, will not happen too often. Yeah. So
limit the damage.
Yeah, exactly. Yeah, I'm missing the word here. So
I get it. You want to basically prevent the rejects, obviously, because it's time and money.
Yeah, exactly.
Rework
so what the overall goal is to always stay in the top area here, where we have the products which are passing our tests. So how does QMULUS help here? So we have an example report which has been created internal or externally. The format of this data, of the results, so for sure you can have it a printout as a report, but in most cases you have a PDF, you have the data being in a file structure, SQL database, or maybe we have direct access to your laboratory equipment, which could also be possible. What we would do then is integrate all this data to QMULUS via, for example, Node-RED. Yeah, so we are setting up a process, not a process flow, a data flow to integrate all this data. We are shipping the data to QMULUS itself. The data is further processed by certain QMULUS drivers to store it in a generic way and to display it in the way you will see later on in the QMULUS manner. So having all the results and the reports integrated, we're exactly where we would like to be. Yeah, so third-party quality data is now paired with the process data and production data, because everything is in QMULUS. This is exactly shown here on the left side. We contextualize the results. That is the important part. Yeah, so having the quality data in hand, the report, and it's just telling you it failed, it's really hard to identify why it failed. But having all the data paired together, you just, with one click, you receive all the process data which belongs to this certain load which failed. It's way easier to analyze and also to draw the right what is it called? Conclusions, exactly. So what are the benefits of QMULUS? We have this holistic view on data, which makes traceability easy. We can create complete compliance certificates, which means we can put together audit results and quality results to satisfy the requirements of your customers. So because they are requiring that you are compliant to the audits, to the specs they are sending, but also for sure the quality data has to be compliant. We can statistically interpret results in context of processes. We can also analyze the results and determine potential process optimization, what I mentioned beforehand. And we can, with this information, tweak the processes to improve the quality results. And this can be done either manually or automatically. And this will be a part of a later session, the statistical process control. Yeah, so how can we use this data to tweak our process in the right direction? Okay, this is more like a background for the next presentation, which is up to come. So this is really important. These topics are really important in your daily business, and it determines how much money you're earning and how successful you are as a company, I think. So and now we are showing you how we solved or how we created applications to solve these problems or to help you, assist you with these topics. So Frank can now take over and will show you the live presentation of QMULUS, as you have seen it already in the last session. So it will be really hands-on.
Okay, I will take over screen sharing. I should be projecting this monitor here.
Perfect. It looks good.
Okay, so excuse the side of my face, but I'm going to be looking at this monitor. And I'm now live on the dev environment of QMULUS. Okay, so I would like to show you, well, the three things we mentioned before. So audit and quality is one of the app's features that QMULUS has. So I'm going to jump into audit and quality. Please remember that I'm super users who have access to everything, but not necessarily every person can see all of the buttons that you would that I'm showing you. So I have here a list of all the reports that have already been done. Okay, but we're going to start with creating a new report, and I'm going to. Oh, sorry. Here's something that I didn't finish before. I'm going to start by creating a new report. So I see here now basically a production log of everything that ran in the last little while. But I'm interested in, let's take it some sort of a 4140 type of recipe, which is a Tesla recipe, which is not, okay. Just a plug there for Elon. So let's take a look, 4140 in the last 7 days. This is what ran in the last month, 4140. These are all the recipe 4140 in Montreal in this case, okay. There must be, here's a Chicago that ran 4140 also, but whatever. I'm going to take a furnace, whatever, the first one, I guess. Take the first one, click. I'm choosing this job here, recipe this, customer whatever, boom, next. So the first thing I got is I can now create a specification, that envelope. I can create that envelope from scratch, or I could load an envelope that has already been done for me. So I'll start with loading and then I'll modify it. And I'm going to answer someone's question at the same time. So load a specification. And here there's a whole bunch of specification sets, and I'm going to choose my famous Tesla. Again, no relation to Elon. And I here have predefined that the name is called main TC only. This is just a name. I could have called it Frank, has nothing to do with reality. But sensors, the sensors in question chosen here are thermocouple interior main. I have, in this particular Night Riders, other sensors. I have a set point, I have an actual on the bottom, for example. So it's not going to work. But if I choose a second sensor, well, I would now have a failure because, no, that's power. What the heck am I doing with power? I don't have my, where's dissociated ammonia power? I was trying to show someone something. I need another thermocouple.
Here we go.
Here we go. Actual zone thermocouple, actual. There, I failed because my zone did this and my actual did this. So let's just play here and say again, the purpose of deviating from my norm here is to answer a question that I did not even read. The question was, can I choose more than one thermocouple? to audit. So yes. So let's take now my set point is 530 with a plus or minus of 56 or 56 degrees Celsius. Okay. So now all of a sudden I should be in zone, I guess. I hope. All right. So there you go. Okay, does not make sense, but now I'm on a zone thermocouple and a furnace thermocouple, which one is inside the zone and one is cascade on the outside. So I have a huge delta, right? Actually, the delta here is a lot less, 539. So if I do 5 plus or minus 20, 25, I think you understand, and we can go in more detail later. But you see, now the time in band was here. So keeping this as my Elon Musk requirement, I now have a band that is failed and a band that is in zone. But now I can analyze this tabular, and from 5:32 p.m. to 5:58 p.m. I was out of band because my conditions, which actually I gotta state some more, were out of band. And then from this time, which is 5:55 p.m. to 1:44 a.m., I was in band with these statistical analysis. Okay, so 7 hours and 49 minutes in band and 23 minutes out of band.
I think, Frank, you should talk about the time sensors, because the question was not about, let's say, auditing 2 sensors. It was if we can select the start point by having more than 1 sensor.
Yeah,
but
okay.
That's what I wanted to say.
I know.
Because you're now focusing on that.
I know. I'm jumping back. Okay, sorry. I got out of sync. Yep. So here are the sensors that are in to be audited. So if I have a load thermocouple 1, load thermocouple 2, load thermocouple 3, I choose all 3 loads. I mentioned that last time, we mentioned that last time, have a virtual sensor called hottest TC, which is the hottest of whatever I choose. And it becomes a TC I could use in QMULUS, regardless. So again, I mentioned this part, I mentioned the duration tolerance, but timer sensor. So a timer sensor is, this is the sensor that will be used to initiate. Let me go back to chart because it's better to show graphically. This vertical line here is the one that is the stopwatch. This starts the time, which is soak time. Okay, so it's a time in. This time in is defined in this particular case when both the zone TC and this interior main hit that that band. But if I remove now the zone TC, right? Now all of a sudden what I have is.
Oh, Frank, you should remove the other one because the zone starts earlier to be high. You need to remove the interior. That just to make it visible. You know what I mean?
Just to make it visible, yeah, because it trips later for the same reason. Okay, so let me undo. There, right? So now my zone started here. My timer started here because zone TC actually hit in band here. This guy came later. He zone came in here, but still the time they both came into band is still here. But now my 8 hours is, well, 8 hours plus or minus, and whatever. It's a little bit, what we should have done here is have more of like a vacuum furnace with more thermocouples. That's the example we should have given. But the thing is, I don't have good vacuum data in my dev. But yes, it's possible. Okay, bottom line. And we could go more in depth with anyone who's interested, and we could have a one-off discussion as well.
Let me one point here, please. So just having in mind that you have maybe 7 thermocouples and all have to be in band already, yeah, to start the timer. You can easily create your own signals. I think we showed that last time in the webinar briefly. So you can create your own sensors, and the sensor could be named minimum thermocouple reading of zone 1 to our thermocouple 1 to 6, for example. And with this signal in hand, you could also trigger it. Yeah, so it's possible, definitely.
Yeah. Okay. I see that we're 8:32, so this webinar we're kind of late.
Slow.
Yeah, we're too slow, exactly. So my audit, I basically, I got the graphical view, I got the tabular view, and I got the submit. And if I do the submit, I basically am getting to a point where I have my information from the job, the work order, the furnace, the asset, da, 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 da. I basically have my main sensor. I'm dictating what is audited, what's my sensor that determines time, set point, limit, duration, that type of thing. Okay, a little graph, I have my little notes, and I'm done. And this audit report is number 51. And of course, I could always refer to it in the future. That was the original list you saw in the past, and I could print it out and I have PDF and that type of thing.
Exactly.
Okay, I need to jump to quality, but now
be
we're going to
assured
go.
you would find some great PDFs, printable PDFs without too much colors, and yeah, really created to be printed out.
Yeah. I'll jump to quality. So
Yes.
now we're talking metallurgy. All right. Okay. So I have a metallurgical report which looks, let's call it, like,
We can't
forget
see
it. Forget it. With the filter, it doesn't show. So you got a quality report which you have, I don't know, some photographs, you have some hardness profiles, that type of thing. Now, again, that's a definition. So I need, one customer requires that I always check surface hardness. HR 15, boom, check, done. 53 Rockwell, submit. So my report is one thing. Another report might, or another Elon Musk might require surface hardness, white layer, case depth, and a profile, right? So surface hardness, profile, photographs, that's another envelope. That's another requirement. Okay, so this is, let's say, the Boeing 1. I need to do A, B, C. And for the hardness dies for extrusion, I just need to do A and B. So I define A, B, C. I define A, B, or define just D. And that is now a set, right? So let's create, and you'll understand what I'm getting at. And I need to hurry up. I am creating something from scratch. Again, let's choose my 4140. In the last 7 days, I ran my Elon Musk parts here in this furnace. I choose this recipe. Understand that this recipe may have run parts A and parts B in the same job. So I could have a report for A with surface hardness profiles and metallurgical evaluation of microscope, and part B, because it was just a sewer cover of someone's garage. In that case, I just need to do a hardness test, surface hardness test. In that case, I have two reports, very different, in the same job. Now, anyway, I chose my job. I choose my my part. My part is my Elon Musk. So it's a Tesla part. Tesla TSL, was it? I don't remember what my part. No, not description, but part number. I called it Tesla. I think I had a TSL. Brake rotors. There's my brake rotors from 4140. I choose this is my part. And now I add a sample, which means now I put a metallurgical sample, which has a lab mount number 1, 2, 3, 4, a serial number as usual, 1, 2, 3, 4, 5. There's a million of those. A date, and here's my preset. So this is, for example, a preset of some microns versus percent. I don't know what that is. This is Mike's template, and here's my basic test. A basic test I have chosen came up with this table, which is white layer surface hardness. It came up with this micro hardness profile, and it came up that I need to put some sort of a photograph. That's what the envelope, the default was. So I do my white layer, I do my checks, I find out that I'm 12 microns, I found out my surface hardness was 52 Rockwell, right? And because 12 is less than 15, it's a success. Because 52 is greater than 48, it's a success. If I was below 48 and I need to authenticate, I want to overwrite, I can overwrite, save, I write my comments, and Frank Pietracupa has overwritten this. No. Micro hardness profile. The spec in this case, a very simple spec. The set point has been defined where at 100 microns, I need 900 Vickers, and at 200 microns, I need 850. Now I do my measurements, and I do 100 microns is 925. Oops, 925. I have 130 microns because my helper didn't understand what to do and didn't do it at 150. So at 130 microns, I had 890. And here, I don't know, at 190 microns, I had 860. And it's a success because my measurement line is above my set point line. If my 890 was 880, actually, let me go lower, 875. Then all of a sudden it would be a fail because I'm below, and my my surface, my real profile is below my set point. Of course, I can overwrite it and make it a pass. All right. Again, I need to hurry up because we're 8:38. I choose my picture. Here's my 4140. I take a picture and I basically, did it pick it? Yes, I must have picked it. There's my photograph, and I say my sample is nice. And I basically, thank you, Vicky, success, boom. All right, and I now save it. If I were to confirm this, okay, I can, again, I can add an assessment, i.e. add another photograph, or add an assessment, add another micro hardness profile in Rockwell, whatever. Or I could add another sample, which now is my 1045 sample, which I ran in my 4140 recipe, whatever, that type of thing.
Important note here is you can adjust it to your needs. Yeah, if you would like to check surface hardness or a white layer or whatever you like, you can just add in another rows. You can configure them by yourself, can create your own presets, and yeah, really configure them to your needs. I need to hurry up a bit.
We need to hurry up. Yes,
really
I submit.
out of time.
Click submit. Generate the PDF. Here's my PDF. I basically have my quality report. This is my recipe number, my report number, which I cannot change anymore.
It's a load number, yeah, but
load
right.
number, like all the information have been entered, and there's my report. My images. Here's my 1045 that I was about to show you, but we're running out of time.
Yeah.
Fine. Let's jump. Let's jump.
Yes.
Last thing we need to say. No, I have one more thing to show. Very important.
Really, really important.
Very important. Wait, let me go back to home, and QMULUS knows my recipe. QMULUS knows the metallurgy. Now I go to history and trends, and I'm going to go to my M1, and now it knew surface hardness, for example, right? So in the last year, well, the last 2 years, well, take a look at this, right? Schubert is very nice here. I have now here a collection of, in this case, I'm showing you surface hardness over time per recipe, right? So in the last 2 years in this example, these are all the distribution of surface hardness of this particular furnace, right? And as I could see here, this guy was a surface hardness of 423 Vickers in 2024, load number X in CP00172 or 7Z, whatever. And then this one was a recipe CP0018Ed, whatever. So here are all the white layers, case steps. But if I do my sort by CP001, I don't know, 7Z, whatever, I don't know, here. So now this is only this recipe. Filter everything else out. These are all the hardnesses. And now you see here I have here I have an anomaly, here I have an anomaly. And I can now, I won't because I don't have time, click, jump to the production log, take a look at load 7554 that ran in January 2023 and try to analyze why did this surface hardness was much higher than these guys. I'm guessing, ammonia content was stuck high, whatever, something like that. So very interesting. This is another example that QMULUS is taking a look at the holistic view, throwing in all of this information and giving me something that allows me to analyze the performance of the quality of my my process in a very easy manner. Okay. Sorry that I rushed that. I think I know.
No,
Mike,
yeah, it's really important, but we will talk about this later on in a future session, more in detail, not particular about quality data, but about data in general, how we are going to analyze it automatically, and also how we find root causes and the things we can optimize. So let me briefly take over for the last part of this session. I hope you see my screen again.
Yes.
Perfect. So we had the apps in Spotlight. Last topic, trends and compliance. Electronic audits, are they allowed? This is a question we asked ourselves. And Frank can give you just a short overview what he found out.
Okay. So basically the answer is yes. The trends are going that way, and you know that the trends are going that way when Nitrix is doing it, but also when the auditors are starting to modify the specs, allowing more and more definition, defining what is allowed and what is not allowed automatically. And in this NADCAP publication, here are two sections, which if we want to go through questions and answers, we need to hurry up. But basically, yes, I'm allowed. I can apply electronic acceptance of the furnace cycle directly to the furnace record. Done. Kind of what we told you. Imagine when we pick the envelope, all right? I picked envelope Tesla on a recipe Tesla. Great. But it's just one step away that when running Tesla part, automatically apply Tesla envelope. What's stopping us from doing that, right? So time, duration, let's whatever.
In a nutshell, let's say, okay, we are prepared for the full automatic audits, and we are also delivering all the means to do it still on paper with your Excel. Yeah, if you would like to see CSV exported, we would not recommend because we have all the means in QMULUS. You can also do that. Yeah, you can
if
print
I have
it out,
a graph,
sign
if I have a graph, I could export to CSV.
Exactly.
Right, in QMULUS.
That's what I want to say. Okay, sorry for rushing through these really important but interesting and exciting topics, I think. But time is running, and I think in the future sessions it will be really more challenging to put it into 45 minutes.
Yes,
but
I see that.
Maybe we can answer. Okay, one question we answered directly during the session. This was about the multiple thermocouples determining the start point of the heat treatment cycle, which is fine. So the next question, maybe one, and then we close this topic, the session for today. What about can you edit a report which has been done in the past?
Okay, yeah, no. So if a PDF is if I submit, right, then Frank Pietrakupa submitted at this date, this time, it's locked as, was it 51, whatever, report 51, yes. And it's locked. And that report, that material, that Tesla sample, that brake rotor, whatever, is locked in that report forever. I can create a new report, and I can change my specifications and just put another sample in that particular job. In that case, I have a new report 52 with different specs. But in the PDF, I have all of the specs written. So if I show you 51, you'll see what I audited against. If I show you 52, I'll show you what I audited against, which may not be the same thing.
Exactly. And this goes also in the same direction as usual people ask. So if you change later on the preset or the definition of a specification, this does not influence reports which have been already completed. Yeah, so all the specs are stored and saved forever. Let's call it like that. Yeah, so that's clear. Okay, I think that's unfortunately we cannot answer more questions, just one or two more questions which are really interesting, but time is running out. So let's close this meeting by thanking you for attending. We hope to see you again in the next webinar, which is roughly in a month from now, so 11th of December. We will talk about data analysis and data insights, insights we can gain out of the analysis. We just saw a small portion today with the history and trends application, so this will be more like a starting point for the next session.
Great.
Thank you very much. Thanks,
Frank.
Frank.
Thank you, Mike. Thank you, everyone.